practice. Before we start, let me introduce you to our speaker, Professor Bart Lamiroy. He is a full-time professor at Université de Reims, Ardennes, France. He is also a researcher at the Crestic Laboratory. Professor Bart received his PhD in computer vision at the Institut National Polytechnique de Grenoble, France. Over the years, his research topics have ranged from content-based image retrieval over visual surveying to document analysis and classification performance analysis. Without further ado, the screen is yours, Professor Bart.
Thank you very much for this nice introduction. I don't know if I have correct audio return in this room, but I think it's okay. What I'm going to talk about. So it's how to say. I have not very much information of the level of experience of the audience with machine learning, AI, and so forth. So please feel free to interact, ask questions, and be as interactive as you possibly feel comfortable. What I'm going to talk about is a project I'm doing with an artist. And it is related to machine learning and AI, but in a way that is not often encountered. And I'll explain this a little bit further. So what you see here at the screen is the picture of a real painting. No, this is what the AI produced. You will further see what the human artist will do with this. First, let me introduce the scope of this work we're conducting. The problem with artificial intelligence, or what people call artificial intelligence, is that it's plainly artificial. We're not quite sure it's really intelligent. When you play with neural networks and things like that, it does do very interesting and powerful tricks, but it doesn't seem to be very intelligent in the sense that it's not naturally adapting to its environment unless you retrain it, unless you have it, give it lots of data, but it doesn't seem to be interacting or learning by itself. You actually need to guide it very, very, very much. It still remains something that is very engineering-like and computer science-related. It's just a different way of programming in a sense, but you still need a human to do the programming for that. And as of such, it is a totally deterministic program. Once you have a pre-trained neural network, for instance, once you give it the same data, it will systematically produce the same output. So it's, in a sense, it's 100% predictable. And so the question is, can computer programs surprise me? And so why am I asking this question? The question is that is related to serendipity. So as I told you, I'm working with an artist. I'll make clear a little bit further why and what this means. But the question about serendipity is the capacity of finding things you're not looking for. Okay, so I don't know, when you're looking, you lost your keys, you're looking for your keys at your home, and you're trying to find them, and you turn everything upside down, and then suddenly by looking into a drawer, you find an old picture that you had forgotten about, and suddenly you say, wow, I didn't know that I had this picture. Wow, it's very interesting. And so you find you were obviously not looking for, but that is of a computer science point of view. Now, of course, you may all be aware that many software providers or currently very, very successful companies are trying to use this to suggest things to you. These are recommendation algorithms that, for instance, Netflix or TikTok or Facebook will use to consciously or unconsciously give you content you were not necessarily looking for, but that they think will be of interest to you. The thing with these algorithms is that they have a tendency to average out and provide you with a specific profile that is usually a long-term average of what you tend to like. Some of these algorithms, like the ones that are used sometimes on streaming services for music, let you tell them what mood you're in, and then they will suggest content to you with respect to your mood. But then again, it is related to some predetermined algorithms that have been learned on the one hand, your general preferences of music, for instance, and the categorization of what mood is about, and how the average person would react to a specific kind of moody music. But perhaps if you're sad and you want to have some upbeat music, you want to listen to some Baroque classical music, or you may want to listen to some hard rock music or some K-pop or whatever. Depending on the individual, your mood will also not give access to the same kind of inputs that will change your mood. Now, why am I talking about all this? Well, the thing is, an artist, and in this case, a painter, for instance, has often the difficulty of trying to find out what they want to paint. Or something you may be knowledgeable about is writers, for instance. The first blank page is some very, very difficult hurdle to pass over. The writer's block or the painter's block is when you're in front of your white canvas and you have to paint something, or you're in front of your white page and you have to write a story. The beginning is always very difficult because you have to find out what you want to paint or what you want to write, how you want to address it, what is an important topic, given your current ideas, your current mood, and your personality. So this artist I'm working with, Emmanuelle Potier, she's a French painter. She was exploring the concept of denial of choice, and to see how far we actually have the free will to determine what we are going to express as an artist. And she wanted to have a dialogue with an AI kind of software that would question the artists in their creative process. So the idea was that we could try to create some software that the artist would feed with things of interest. I will come back to what this notion of things of interest means. And then the AI would use this to suggest topics of painting to the painter in a language, in this case, a visual language, that would be of interest, that would be of some meaning to the artist. It's not just a standard, well-known kind of formal language. It's a subjective language that is in the head of the artist itself, and it's not a language that is shared with everybody. So this is the kind of the main difficulty of this work, and the main interest. Because you're mixing two kinds of worlds. On the one hand, you have computer science, where you write algorithms, and algorithms need to be exact, and they're reproducible, and they're deterministic. And on the other hand, you have the kind of end user who lives in a world of representations that are subjective, that are intensely personal, and that cannot be expressed in some common language. I mean, the feelings you have, the impressions you get by living, observing things around you, all these kinds of things that actually then create the urge for an artist to express things, to send a message, in the shape in which this message is sent is totally, entirely individual and determined in the brain and the mind of the artist. And it's not something that is belongs to the common language. And so working together between computer scientists and the not computer scientists on this domain is very interesting, because expressing concepts and trying to transform them into code, something you probably know how to do have learned to do during your coding courses, where you express the needs of the user, and then this gets transformed into some kind of specification document that you can model and then code and express in some programming language, is not something that works here, because the way of expressing things is highly subjective. But then again, it still has some common vocabulary that we can rely on, because a painter has a set of tools to they talk about colors, they talk about textures, they talk about strokes, they talk about many kinds of things you actually can translate. But the concept of creativity, the concept of what happens in their brain, in their feelings when they try and paint things, this is something that goes beyond this standard vocabulary. So the main idea was to create software that would stimulate the process of inspiration and creation. And that is the thing that sparked this work. So how do we go from the creative project process that is very subjective to some technical goals? So again, the creative process is something that is subjective, that belongs to an individual user. There's no one and unique way to do this. We have chosen this one because it relates to how this particular artist's works and proceeds in doing her paintings. Many other artists may have similar processes, similar ways of working. Others may have completely different ones. So this is just a first step into modeling one kind of approach to creativity and inspiration. So some of the hypotheses we have used is that when an artist wants to paint, they have a project to develop some or create some artwork. They usually have some role models of iconic artworks. Someone may be totally in admiration for Picasso or from Goya or whatever kind of painter or class of painter. They may be very impressionists or cubism or totally non-figurative kinds of painting. So there are some iconic artworks that are of a particular meaning to an artist because of their history, because of their way of painting. But then creating some works also requires some inputs, some triggers that are emotionally charged with some meaning to the artist. And maybe the artist just recently fell in love with somebody and has a drive to express this feeling because and needs to be reminded of the hair color of their partner or the country they live in or whatever, or they may be touched by current events because there's a catastrophic events that has happened and they want to express their feelings about this or anything about that. And then also often artists may have self-imposed creative constraints in their works. For instance, let's say I only want to paint in blue, or I want to use specific visual vocabulary by painting only animals or painting only mountains or stuff like that. So sometimes projects also get very constrained because of restrictions the artist imposes upon itself. So if we want to create an artificial intelligence, we want something that captures all these cues that are mentioned above. Okay, so if an AI wants to reflect on what the artist wants, it has to know what role model iconic artworks the artist has to know about the cues or the events that create specific emotions that are of interest to the artist, and has to be aware of the fact that the artist may have self-imposed constraints. And if the artificial intelligence gets it wrong, then we need to be able to create some kind of dialogue where the person who is using the tool may say, well, this is what I like, this is what I don't like, and then have this kind of iteration. But of course, this is the hard part for the computer scientist. This has to be sufficiently independent of such that you cannot easily predict what the AI will produce to be able, and so in such be able to surprise the artist. So we've taken some shortcuts, some constraints in what we're doing. The definition of a painting, in our case, and this is especially true for figurative painting, it's less true, or it's more difficult to express in non-figurative painting. But the main two parts of what defines an artwork is its structural composition. How objects are positioned in the scene, what is their relative size, how they are related to one another, on the left, on the right, above, under, and these kinds of things. And to put together, they kind of define the structural position of a painting with their anchor points and their relative sizes, for instance. But that's not the only thing that, of course, defines a painting. It's also its overall pictorial style, and the colors that are used, the textures, the kinds of strokes that are used in order to reveal the actual physical act of painting. So how do we capture this? How do we capture the structural composition and the overall pictorial style? Then, of course, we need to be to capture the emotion procuring events or cues. They're by essence multimodal. They can be sounds, they can be images, they can be smell, any kind of sensation can procure these emotions. In our case, we're restricting ourselves only to visual inputs because of time constraints and resource constraints. Further work will explore other modalities, of course. And this is, if we are able to capture the visual inputs that an artist cares about, we can put this in the process. Then, of course, the artist may have self-imposed constraints. These can be compositional restrictions, or also the pictorial language the artist is going to use. And this is something that is important in what is going to follow. The artist can define how he or she wants to express particular things in their painting. In order to be able to create a dialogue, it must be easy to use. It shouldn't be something that requires hours or of training. If we're talking about supervised or self or auto-supervised learning of neural networks, if you have already played with those, it can take a vast amount of time and an incredible amount of effort, providing many examples and many hours of GPU computing to actually come up with a network. This is something we don't want to do because it has to be reactive. It has to be able to adjust and react in a very short period of time to new ideas from the painter. So human input should be easy to change, and it's not the act of programming that is going to change it. The artist just wants to click on a button and have a return that is interesting to him. So the overall solution we have come up with, the general AI process, is so what you have in blue is what the artist will provide to as input to the system. The yellow, orange boxes are different phases of the algorithm, which we shall detail, and it's many of it is based on neural networks. And the green one is then the output. So it will take as an input some iconic artwork the artist cares about. It will get access to what is the visual universe, the pictorial universe the artist wants to use. And some background image we will detail later. And it will mix all of that together to provide a new image that is a chimera of the previous ones. It's kind of mashup, mix-up of all these things together that is that looks familiar on the one hand. You still find the structure of the previous things, but it is sufficiently deranged, sufficiently strange for them to raise questions in the head of the artist and create the drive to paint something. Right. So if you look at the general process, so what's going to happen is that the AI will look at the artwork and try to decompose it, to say, well, I see things in this artwork that are of importance in the composition of the artwork. So various kinds of pictorial representations, their relative positions, where they are, how big they are, how do you relate to one another. So the artwork will be analyzed and decomposed. And then, let's say at some point we see a person in an image. Now, the visual universe that will have been provided by the artist and the constraints the artist will have provided consist of saying, well, to me, a person has to answer to these and these and these constraints. For instance, I may have a project that where I want to paint only with figures from the Marvel universe, for instance. Okay, so every kind of individual I want to paint has to be a superhero from the Marvel universe. So the AI will then say, well, okay, in this artwork, I have identified three people standing or sitting or lying somewhere, and we'll go to the visual universe of the artist and recompose an image using, for instance, this Marvel person. And then all of that will be projected back on a background image that is of also particular interest to the artist. The artist may want to have a project to revisit the images of the past where he or she was staying at their grandmother's house over the summer or something, and so take pictures of this area, this time of their lives, or this time and space, because it's of various interests. And then all of that will be combined together, and we will apply some style transfer for it to look somewhere look similar to the initial artwork. So first of all, so we're now going to dig into the scientific part, the technical part. So on your left, you have some well-known painting, Renaissance painting, Italian Renaissance, Piero della Francesca, showing it's some well, anyway, it's not really important. What we can see here is that current state-of-the-art semantic segmentation algorithms can be used, so neural networks can be used to actually identify objects in this painting. For instance, it has identified several persons standing at various sizes, standing or sitting in the scene. So we can identify those, segment those. They're associated often with the kind of importance or weight as you can see, the algorithm is more or less certain that there is a person or not in various areas. So what we're going to do, so yeah, this is the reference that we have used. It's fairly old now. Master CNNs are something that are now very mainstream. There are quite a lot of them, and current neural networks actually have vastly better performance. But we've took this one, 1917 ICCV paper on master CNN. So this allows us to segment the image and get labeled and well-defined areas that are of interest. I maybe go back on so yeah, how does this work? Neural networks. This is kind of a question I have for the audience. Have you things you know about, or how this actually works? Can you give me some feedback? Is this something you already know about on a technical point of view, or should I go into some details explaining things? Please. No reaction from the audience. I hope you didn't all fall asleep while I was talking, which is
someone raised hand. I think Professor Bart Ryzen, I think.
Yeah, perhaps I could give an answer on that. So I think it depends on. So in our university, we have like a path that we can take, mainly studying AI. So we take it on the 5th semester, if I'm not mistaken. So I'm currently on 6th semester. So yeah, I've taken studies on this neural network, machine learning and stuff. Not sure about the other participants here.
Okay. So what I suggest then we do, if part of you have seen these kind of things in their classes and are relatively familiar with them, and others have not or are in a lower year will have see this next year, for instance. Maybe we can keep this for the end of the talk, and then if some of you say, well, this is interesting, explain to me how this works, I can go over that for those who are interested. Those who have already seen these kinds of tools and know how they work, then can proceed to or ask other questions. So just in a short synthetic way, so neural networks are combinations of very, very small computations that are similar to what happens at a very high level of abstraction in our brain, where very small computations are done, which are essentially making sums of inputs, and if the sum of the inputs is sufficiently high, then it will be transmitted to the next layer in the network, as do neurons when they get input at some point, electrical signals, and then proceed by transmitting it to the next one or not. And with that in mind, you can construct several kinds of architectures of combining information. The ones that are used here are essentially convolutional networks. So these are the CONV boxes you see in the middle of the image, where the system, the neural network, will learn by example what kind of combination of pixel colors or pixel densities or pixel arrangements are how to say, an indication that a person would be in the image, or ball would be in the image, or a tree would be in an image, or a boat, or whatever. So it has to be given a certain number of well-defined categories, like cars, boats, apples, bananas, humans, horses, whatever. And then, given sufficient number of examples, it will learn how arrangements of pixels at various levels are constituent of any of those classes. Now, the masks there are CNN. So this is kind of the classical convolutional network, but in the title stands for the CNN. The fact that you have also need to actually identify the pixels in the image where this occurs in a precise way adds another level of detection where you will try and find the best fitting areas where your convolution works best. Well, we can go back to the details if that is of interest to you at the end of the paper. Otherwise, it will start to get fairly technical at some level. Right. So now that the fact that we can identify objects in an image and see how they relate to one another, we actually are able to capture the compositional language that is used in the iconic artworks. So the artwork is translated into relative position of various kinds of objects onto the plane of the image. And since this is, these are pre-trained neural networks that are off the shelf, they are very easy and very fast to use. You don't have to train them or anything. They actually work out of the box. What is very interesting and very funny is that most of them are pre-trained on real photographic images of the real world. They're not trained on paintings, which results in some slightly erratic behavior. It sometimes gets things wrong. And this is funny because this is what we're looking for. We don't want an exact program that is boring. We want something that is creative. And of course, if we want it, we can pre-train it. We can tell it should readjust to its initial learning. And it's evolutive. So we've used a fairly old network, but there are currently other networks that do as well or even better, and we can actually plug and play with different networks. So that was the first part. So you have this in the middle, this person in yellow that was extracted from the image. Now, as I told you, a person translate into something different in the mindset, in the visual language of the artist. So the artist will have provided a definition of what, in their sense, is a person. Maybe in their project, they want to work only with their relatives. They want to substitute famous person in pictures with their sister, their child, their grandparents, their uncles, or their beloved ones. Or other things. They can be, as I told, for instance, Marvel Universe superheroes or Mickey Mouse or whatever. So the artist can provide their personal environment that is of significance to them. And then it is fairly easy to recompose the image by repositioning these individuals in the image. So this allows us to actually capture the subjective emotion procuring inputs, right? If you look at a picture of some anonymous 15th century Italian painted person, it's not the same thing as to look at your brother or sister or mother or father in the same configuration. You won't get the same subjective return when you look at these images. And it also captures the possibly self-imposed creative constraints, because if this is, I don't know, Superman or Captain America or Wonder Woman, it also adds to the constraints that the artist may have created. So this is another way to capturing the artist's personal subjective mindset. And it also allows to create a dialogue. Suddenly the artist says, I'm fed up with Marvel Universe, I'm going to use DC characters. Okay, you can do this. You can use Pokemon. You can use whatever kind of visual language is of importance to you at this time. And so what happens is then that the image is recomposed with the visual language of the artists by superimposing people in the original image. And then again, also, the artist may maybe not be very, very interested in neoclassical backgrounds with ionic pillars, for instance. They want to set this picture in a newer background with some things that are also within their visual language. And so the final recomposition of this initial artwork is what you can see on the right. So it's respecting the general composition of the original painting, but it's created as in a new, totally new setup. Of course, this created image is, from a pictorial point of view, not very, very nice. You can see that there are some cutout effects. The colors are not homogeneous. You have many, many artifacts that are making this just like some person just cut out snippets from journals and just glued them on some background. So this is not really a nice thing to see. But now then what we do is, so again, this is the fact that's allowing us to adapt to the environment. So what we do at the end is that we take the constructed image, as you can see at the top. It's another one, but it's based on the same initial Italian painting from the 15th century, and then transfer the style of the original painting onto the new image, and which procures not something completely new and surprising, because on the one hand, it does resemble the originals, but in the end, it is fairly different. It's surprisingly different, although there is some familiarity with it, right? So you can kind of identify things, but it still is strange enough to ask questions to the AI. The artist will say, well, what is this? How is this related with my mindset? And then they will look into it and discover things. And looking into this, they will create a creative process. Doing style transfer, again, is something quite interesting, using, again, convolutional neural networks. The paper, again, was published in 2016. It's a very classical way of doing things. Now, the way this works, and you may probably have already seen this, is that when you do image convolution on various levels of precision and various resolution levels, what happens is that on the one hand, the higher you get in your the lower the resolution you get, so the more you stack, the more you do convolutions, the less detail you get in the image. So if you look at this Van Gogh painting on the left, and you scale it down by doing convolutions, and then to try to reconstruct it using local information, the style is concerned. If you use lower resolution, you will have this very noisy but very interesting texture. You will have access to the small level texture of the picture. you can see on the bottom right of the picture, these kind of small dots. If you go lower in the resolution and you go to the end of the pipeline, you will capture more of the global structure of the patches and the color themes that are important in the image. So at all the levels of the analysis, you get various informations of the structure, the texture of the painting with respect to the artist's painting strokes, the color sets, and the general feeling that flows out of the painting from its structural part. If you look at the picture on the downside, the lower the higher the resolution, the more to the left, the more details that you capture. But and when you go very, very low in resolution, things get very, very distorted. And so the kind of the level where you can still kind of recognize what's going on and have the global structure of the painting with its main contents, but without many details, is the level that is labeled D here, because the one before the last level, that is kind of significant of the general composition and objects that are in the image. So this is something we want to maintain. We want to maintain, on the one hand, the general composition and the objects that are within an image without taking too much attention, making too much attention to the details in the picture. On the other hand, we want to capture all kinds of structural importance of the painting itself, the stroke with the colors and the general movement that is peculiar. So using this, here again, we have some neural network language that is used, and the algorithm we're using is that on the left-hand side and the right-hand side, we will take a picture, both the artist's painting and the photograph, and have it go through a convolutional network using 5 different layers. So at each level, we're losing resolution and we're adding convolution. And then what is interesting is these equations you see on the left and the right. So what you have to see is that in the middle column is going to be the generated image. I'll come back to that a little bit later. I don't know if I have the slide. Yes. So as I told you, these are pre-trained standard VGG convolutional networks. And we're going to extract these feature maps at various levels from these 3 images. Let's forget the one in the middle for some time. We're going to focus on the left and the right. Now, on the left-hand side, we are going to measure the difference in style between the middle image is the one that's going to be generated and the left image that is the one that is provided. So style loss is based on what is called gram matrices. A gram matrix is some kind of simplification of the convolutional features that have been computed. And it allows us to actually compute a simple difference between the left and the right image where style is concerned. So we're going to compute the differences in style. So that's what you can see at the top. The loss function is essentially the difference between the features that were extracted based on the gram matrix. And this gives you a measurement between the left and the middle image where style is concerned. So we want to minimize this distance. We want the style to be as similar as possible between these 2 images. So this is just a simple minimization problem where style is concerned. On the other hand, we also want the features that are extracted from the right image and the generated image in the middle to be as close as possible, but that is only on one particular level of the convolutional network, so that we capture as much of the structure as possible between the two images. So now that we have this, we want to combine those. So we want to have as close as possible similarity in style, and as close as possible similarity in structure, which are expressed by these two equations. And then finally, this boils down to finding in the middle, finding the image X that is the image that minimizes this total loss function. And the way we do this is some standard gradient descent algorithm that is well documented. Starting with a white noise image, so we take some random image from the beginning with just black and white pixels. And then using a gradient descent algorithm, it's fairly straightforward to actually converge there a new image using multiple iterations that will try and minimize this loss function. And by doing so, doing so gets us back to this result, which is a very standard. You can find it many places on the internet, and especially in the paper that we cited here. So where you will have your favorite vacation picture, in this case, in a small town in Germany, painted as it were painted by Van Gogh in the same style, but where the general shapes of the buildings, even some kind of colors are maintained, but globally, the style that is applied is the one that Van Gogh used in his paintings. So again, this goes back to our creative process goals and ideas, because it will reflect the role model iconic artworks, because the final result will resemble in some way to the art domain or the art movement or the ways of painting the artist is interested in. Again, it will preserve the emotion procuring inputs, in the sense that many of the things that were put in there remain recognizable in some way. And so, as again, this AI then captures the inspiration cues of the artist and has sufficiently independent behavior to surprise. So now that we have this algorithm, we can see how this can impact artistical practice. So we have given this to artists, one in particular, Emmanuelle Cotier. And so she feeds it with whatever she feels like. And the outputs of what is given to her provokes the willingness to do the urge to paint. But the thing is that, well, so what you see on the right-hand side is not what is generated by the algorithm. On the right-hand side, you see an actual painting produced by a human artist, inspired by what the algorithm called La Muse actually provided. So what happens is that the artist will look at the image, start and try to paint it, but then by painting it, will look at it in a different way and see details. These details will then, again, evoke emotions and will help the artist focus on part of the image, reflect on it, change it, and get the process moving. So that there is no a priori idea of painting. The artist receives the image from the algorithm and then has to digest it, has to work on it to actually produce a painting. Oh, there's a word missing. This is actually the very first painting that was created with La Muse. And so the interest of this thing is that it actually surprises. It's a modification of routine. We've interrogated other painters. Some of them are very enthusiastic because they see an interest in their own practice of painting. Other painters are very reluctant. They think this is going to be an intrusion in their personal perception of painting. They seem that the AI is going to impose itself upon them by reducing their liberty of thinking or practicing, which is of course okay. I mean, nobody has to use the tool. It's just a tool that exists and that they can use. It's kind of it's not an imposition of its own will. It's just trying to engage a dialogue with the painter in some sense. And the idea is to have this going back and forth, but with the painter offering things to the algorithm giving things back, and having a creative process in that effect. Okay, now further work, we've continued playing with this. So, yeah. Now the question that arises is what's the use? I mean, if you look what DALL-E 2 can do, I don't know if you're aware of this. I think you are. It's been heavily reported in the media. I mean, the quality of the images our algorithm produced aren't as close as can. I mean, what DALL-E 2 does are very, very impressive images. Ours are kind of weird-looking things, and this is a real difference because, of course, DALL-E 2 doesn't rely on the same resources we are using. They have huge amounts of GPUs. They have large industries funding their works, but the goal is not the same. The goal with DALL-E is essentially what is called, it's very close to generative art. It kind of generates items that are predetermined. If you want to constrain DALL-E to work on the personal vocabulary an artist uses, for instance, you will have to retrain things, or you have to integrate this in a very strong way in the algorithm. There is a tool by Facebook, developed by Facebook, that is called, I think, Seer, that does things where you can actually modify the pitch or the instructions you give to the algorithm, but it doesn't go into as much detailed substitution as ours does. And also, the one we are using is very low impact. It's very low footprint. It can run kind of any computer. It doesn't require very high computing power. And again, the idea is to create an interrogation in the brain of the artist. Its goal is not to say, wow, this is a very beautiful image created by AI, because this is not what the human artists want. They don't want to be sidelined by AI. They want to kind of keep their job as a human painter. They don't want to be, well, if suddenly the AI does exactly what they want to do, there's no use for being a painter anymore. So this is kind of the difference that is between the approach of tools like DALL-E, which are impressive and use a very high state-of-the-art things that the one we have developed. And also, this is not generative art. Generative art is something that is considered as, let's say, art produced by software, and that is considered as an artwork by itself. Okay, this is open to discussion if you're a purist. If you look at the definition given at Wikipedia, maybe what we're doing can be considered as generative art. We rather want to see it as a toolbox for painters. an intelligent toolbox that helps human artists to actually be more creative. So this is the end of the talk. It is not very technical. It's kind of an open to discussion thing to have an interaction to see how software development, how toolbox of technical solutions based on neural networks can actually go beyond what traditional computer science machine learning does. One of the things I do in my research related to machine learning is to actually evaluate how good tools are performing. And this is something, if you're studying computer science, is something you're very well aware of. I mean, you want to, if you write code, any kind of code, you want it to be bug-free, you want it to work perfectly well. If you do computations in your software, you want the results to be correct. If you do neural networks, you usually have a benchmark where the system is measured with respect to how well it performs in, what is it, object recognition or automatic translation or text generation and so forth. The general mindset within computer science and software development is to have something that is of perfect performance, and this perfect needs to be measurable. What we're trying to do here is something that is very, very difficult or even impossible to measure, because it's every individual will have a different reaction to what is produced through our tools. What may be considered a very inspiring picture for some artists may be considered completely dull and uninteresting for another. And so there's no way of actually measuring things beyond just using it and having feedback from those who use it. But the thing is that we want this tool to be surprising, having glitches and strange behaviors that actually question the artists on the tool itself and on their practice. And as such, it becomes something that is mathematically much, much, much harder to evaluate, or even is not possible to evaluate. We haven't worked it out yet. Okay, so this is kind of the end of the talk right now. I am totally open to exchanging with you, asking questions, going to more detail and technical point of view. One of the things is that you can also play with it, you can test it. It runs on a very, very small, low capacity demo server. And since this was done with essentially my students back in France, the tool hasn't yet been translated into English. But if you want to play with it, you can go to the website, create an account, and then just upload some images and try to see what happens. We deliberately gave no direct guidelines on how to use it, so that people can actually play with it, have a personal way of using it. There is no imposed canonical way of using it. You can just add images, run it random, use specific images. You just play with it and you can see how it works. Of course, if all of you will connect to it right away, right now, it probably may not crash the server, but it will slow it down significantly. But go ahead. This is just to show that this works and gives sometimes very surprising results. You can also go to the website, create an account, and browse all the things that have been created up to now in the boutique section. So this is it. Please, I'm open to any questions, remarks, interactions you want to throw at me. Thank you very much.
Thank you, Professor Bart, for the interesting presentation. For all participants, if you have any question, you can raise your the hand and ask directly, or you can type it in the chat box. appreciation from the participants. Yeah, Ryan.
So let me give you one. So from my super minimalistic experience, looking for a job here, like between 4 months ago, what I've seen is jobs regarding machine learning or data science, etc. Here, particularly in Indonesia, it still have a minimum capacity. For example, if you look for data science jobs, the company will open 4 seats for it. But when you compare it to like software engineers, they will have like 20 empty seats, etc. So I'm curious to see your perspective of this, especially as a European, how data science jobs is doing out there, and how do you see it will like improve for the next decades or so? Thank you.
Okay, quite an interesting question. And so, of course, I am totally incapable of saying how the job market will look like in 10 years. I mean, there are so many factors that are into play. And 10 years ago, I mean, the actual deep learning kind of craze is only 10 years old. I mean, 15 years ago, nobody ever expected these deep learning things to work. I don't know if you know the story behind all these things related to deep learning, but actually the actual director of Facebook research developed the gradient descent algorithm for neural networks in the 1980s. And he was considered as being scientifically insignificant for 20 years, and he kept going and working on it. And suddenly, GPUs allowed them to actually do the computations that were needed, and we discovered deep learning. So there's no way anybody can predict what the job market is going to look like in 10 years. But then, I do understand your question. There is in Europe and in North America huge. I can consider probably in other countries in Asia as well, China, Japan, Korea. These are the ones I know. I must admit, I've as my colleagues here at Venus know, this is my first time in Indonesia, so I must admit I haven't got a clear view of the Indonesian labor market regarding to IT. So please, I apologize for that. But I suspect that in the coming years, data analysis at large, machine learning at large, will require quite a large amount of jobs. Now, one of the things that may be important to consider is that I suspect that part of the software development market is going to actually be concentrated on very specific, very high profile jobs. But what I can see in the needs and the job offers in Europe, for instance, on data analysis and machine learning, they are huge. They cannot fill all the offers that are open. So there is, if you have the drive to try and go international, and if you say, well, I see an opportunity to do a master's degree or a PhD degree or something, or try and work for a company that is not necessarily in Indonesia, I think there are great opportunities. Now, predicting how this will work out in 10 years, I wouldn't be able to say that. There's in Europe, for instance, much more offerings in IT and computer science related to data analysis, big data, and machine learning than there are in traditional industry. But then again, civil engineering is also going strong, but not as dynamic as these digital-based jobs. I don't know if this answers the question you were asking.
Yeah, that's enough. At least I get an insight from you. Yeah, thank you.
Yeah, thank you, Ryan. Is there any question from the other participants? Maybe I would like to ask Professor Bart, since it is the deep learning one, for the data set, is it harder to gather for the artistic one?
So I'm not 100% sure if I understand the full scope of the question. One of the things I did cheat a little bit in this talk because the neural networks we do, the machine learning that is related to these deep neural networks, we haven't addressed this in this work. We have currently been using pre-trained networks on standard data. We could, and we are trying to pursue this work, but we could try and actually retrain the networks on the artist-provided data, for instance, doing incremental or transfer learning or fine-tuning of the networks. One of the things we kind of are curious about, and the thing that maybe not work as good as we think, we should try it, is that if a network trains too well on the user's data, it'll get boring. It's like the Netflix recommendation algorithm. You end up looking always at the same kind of movies because Netflix knows what you like. And this is not something art wants or artists wants. This is why I put serendipity in the title. An artist always wants to be challenged, always wants to be pulled out of his comfort zone or her comfort zone, which is not something the current recommendation algorithms or the deep learning algorithms actually can easily do. Because the difficult thing of pulling people out of their comfort zone is that if you don't pull hard enough, they stay in their comfort zone. And if you pull too strongly, they will be too far out of their comfort zone and they will be uncomfortable. But really, I mean, not uncomfortable. They may experience whatever kind of feeling, negative feeling, disgust, or pain, or being totally disoriented. So you have to be able to pull people out of their comfort zone sufficiently for it to be productive. If you pull too hard, it becomes unproductive again. It's like when you're doing your physical exercise, right? If you want to make progress, you need to go beyond your limits to develop your technical or your physical skills. But if you go too far, you will hurt yourself. So with this, you're kind of in a similar situation where you have to fine tune, and this is very hard from a machine learning point of view. I don't know if this was the kind of question.
Thank you, Prof. There is a question from Jason, Professor. When I upload data into Lamuse, will the trading data be kept permanently in the server?
Yeah. I was. So yes, yes and no. So this is a small demo server. We currently don't have any funding to actually operate it properly. So first of all, you have control of your data. So if you should be able, while you're navigating in the panes where you have your data, you can erase it, and I can guarantee you it's effectively erased and it's not kept. If you don't do anything with it, it will remain on the server. And so one of the things is that other users don't have access to the things you upload. They do have access to the images that are generated, but you have total liberty and freedom to actually erase your own data. What will happen is that in some foreseeable future, this will probably be migrated to another server, and then we will probably proceed in a reset of all accounts and delete all data. So there are no worries. Of course, please be careful. Don't put any illegal images on the website. I do have total control on the server, so I will and forcefully will erase anything that is offensive. I hope this, Jason, I hope this answers your question.
Okay. Right now, there's Nicholas who raised hand. Nicholas, please free to ask the question.
Thank you very much. Hello, Professor Bart. Thank you very much for the presentation. I think it's very insightful, especially as it is very interesting for me. I'm actually quite curious in the ethical side of this matter, because as much as this is not actually generating, I mean, the machine doesn't generating the image by itself, it's actually referring to something else. So my question would be, even if let's say the language is actually generating an image, who would be the ownership of the image? Let's say something like that. Because previously I read an article regarding, and that is quite similar about this, which is publishing a paper that is actually made fully by artificial intelligence.
Yes.
And this is actually a kind of similar things, right? I'm just curious because the first and foremost thing that they have issue is the ownership of the creation. In this regard, who will be the position, the owner of the generated image?
So, are you asking me this question from a legal point of view, or are you asking me this question from a more philosophical point of view?
I mean, I'm interested in both of the point of view, but let's just say for now, maybe it's from the philosophical point of view.
Okay, thank you, because I wouldn't be able to answer you from a legal point of view. I think lawyers and law are having a very hard time currently to actually try and determine who is owner of what in this these kinds of processes. I would say, I mean, this. So we have written this software. I have written this with help of my students. We have written this with inputs and collaboration with the artist I mentioned, Emmanuel Cotier. So I would say, like, kind of the intellectual property of the algorithm kind of is ours in a sense. Now, since this has been published and publicly made available somehow, it's kind of just we have this pseudo intellectual properties. We invented it, but it's using tools and software coming from other contributors. So this is kind of open software that can be reused in any kind of way. So we don't own it in this way. Then, since we are not kind of offering this as a service that you pay for, the ownership to me is the person who has had the idea of providing and combining the images. But it's a very tricky question, because if I take, let's say, I provide to the Muse 2 images that are with a strong copyright, because I have taken stuff that is belongs to someone else as a picture, and then the algorithm constructs something that is a mashup of this. This will very strongly depend on what country and what the law says about this. And as always, things are tricky in art. Where is the difference in art between I am inspired by another artist or I am plagiarizing another artist? Finding the limit between those, finding the at what point inspiration becomes plagiarism is something very, very, very difficult to determine. So I think the most important thing is the intention that is behind it. So if let's say, so for instance, the company Disney is infamous for trying to sue people in court because they use depictions of their visual environment, and they don't want you to do it, and they will sue you if you kind of draw a picture too closely resembling a picture of one of their heroes. I don't know if you know this. There's another what is it? Situation. These Belgian comic strips from the 50s and the 60s by Hergé called Tintin. Their rights owners are suing almost everybody who is trying to use the image of. So putting these kinds of images in the algorithm and then that outputs something that vaguely resembles this. I don't know how this will hold up in court. I'm not a lawyer. I think this is fair use. I mean, you usually have the right to reuse stuff as long as it's significantly different. But then, yeah, it's a very interesting philosophical question. We could debate on this for a long time, I think. But like artists have been forever being inspired by others. So, I mean, if I use the algorithm on copyrighted material, but then I look at the finally produced image by the algorithm, and then I start painting it on a real paint canvas with real paint, and I change it again. I don't think this is plagiarism. This is just plain reuse and inspiration. But maybe a lawyer maybe consider that as something different. And what is your opinion about this, Nicholas? What would you say?
This is actually something that I have been thinking about lately as well. From my point of view, I think it should be the algorithms. I agree. It should be the algorithms' rights regard of the position of the image that they generated by itself. But it's a machine. Right, because it's a machine. They don't have actually like the actual ownership of the image that they have, because it's probably belongs to the creator of the algorithm, right? But then again, it's not really what the creators. The final product is what the algorithm creator made, but rather the user of the algorithm. So it's kind of like a gray area for me to decide which one is the actual owner of the image.
But I think it's a gray area for almost everybody. Some similar and more, I'd say, serious question is: suppose you have sufficient money and you buy yourself a self-driving car, be it Tesla or whatever, and you are not driving your car, you're in the car and the car is on autopilot, and it crashes into a pedestrian and kills the pedestrian, unfortunately. Who's responsible? It was your car, you were in there, so you could have switched off the autopilot. Is it Tesla or the auto constructor, or is it the programmer or the team of programmers who wrote the AI? Or is it the AI itself? Who will end up in court and paying for the damage? This is a terrible question by itself, because people can get hurt or killed or something. But then starting to think of it, I don't know. Who is responsible for in this kind of situation? Is it a shared responsibility? Well, and then ownership goes with that. I mean, I own the software, but how responsible am I for owning software with bugs in it? If you're like, we are all here, most of us attending this session here are computer scientists, so we know about programming, we know about computers, we kind of know how they work, sort of. But maybe your grandparents or your other relatives, they're not so knowledgeable in computer science, so they just buy software and you expect it to work. Well, it doesn't always work. And as a computer scientist, you can understand that, but as a non-informed user, so how responsible are you for using buggy software that creates damage? So it goes with the ownership thing that is related here to the artwork. Can you be considered as a plagiarist because the software you use suddenly produces something that is already owned by somebody else? Interesting. I don't know the answer. I really don't know the answer, and I think many people don't know the answer.
I see. But I think your insights about this matter really opens up the possibility for maybe some few answers. Thank you very much, Professor Bach.
You're welcome.
Thank you for all participants and Professor Bart for today's session. Before we end our session, maybe we can take a picture together first. All participants, feel free to open your camera. Mr. Abram, can you help me to take the picture?
Professor Bart, would you mind to stop sharing so we can see? Yeah, thank you.
Okay, I have a page, so first page I will take everything. Okay. 1, 2, 3, 4, 5, 7, 8. Okay, enough. Thank you, everyone.
Okay, thank you, Professor Bart, for sharing to us for today's session. For the participants, don't forget to fill in the attendance form. Thank you.
Thank you, Professor Bart.
You're welcome.